All right, everybody, welcome to Tesla Today. I'm very excited about this episode. I've been waiting for it for a long time because two things happened in the last month that will tell you that full self-driving, Tesla's Autopilot full self-driving technology is actually coming closer than you think. I'm convinced that it's going to come not only maybe by the end of this year, like Elon Musk has been saying, but certainly by next year. And the two things that's happened, one is that they've now turned their supercomputer Dojo online. And then we're going to show you videos from director of the Autopilot team, Ashok Elaswamy, who's going to tell you a new technology that they created called the General World Model. So I've got Dr. John Gibbs with us. He is known as Dr. Know-It-All on YouTube. It was his two videos that he did recently. I'll put those links in the description, where he walked us step by step in the two videos. That was just two presentations by Ashok and Phil Duan that showed the details of this new technology that they created. And so I'm really excited. Thank you so much, John. Thank you very much for joining me. Finally got you on.
Absolutely. Yeah, I know. It's been a very, very busy summer. It's been chaotic, but anyway, I'm super happy to be on. You were one of the people that I was like the most interested in talking to because you, number one, you ask fantastic questions, but number two, you're just an awesome person. And by the way, I hear we might be seeing each other in person in Vancouver because I'm trying to get to the fully charged thing there. So
oh, yes.
You're going,
okay.
Yeah, Brian told me you guys might be driving up together or something. So anyway,
yeah,
super cool. So I look forward to that when we hopefully get the chance to do that in person. Cool.
Perfect. Thanks. Okay, let's get started. So first of all, I want to set the stage of what we're talking about. So there was a workshop on autonomous driving that was done on June 20th. So literally less than 3 weeks ago. This is why, oh, I'm sorry. I think I picked the picture of the 2022.
Yeah, you did. I was wondering because I was like, it's not in New Orleans. It was actually in Vancouver this year. So I was like,
okay, sorry.
Anyway,
picked the one that happened last year.
In Vancouver there, and it'll be fine. Yeah.
Okay. Oops, I made a mistake there. So this is Ashok Elaswamy. He's the director of Autopilot software. And he was a keynote speaker. And Ashok actually is the very first employee hired by Tesla to lead their Autopilot and full self-driving technology. And he's been there for 9 years, almost 10 years. So what else did you know about him?
Well, he also has a degree in robotics, not in artificial intelligence specifically. So that's actually a really interesting little tidbit because, of course, Optimus and of course, the cars themselves, like the vehicles are robots, obviously, but I think people would consider Optimus to be even more of a robot for whatever reason, probably because it has 200 degrees of freedom as opposed to like 3 for the car in terms of the output control. But anyway, I found that a really curious thing. I did not realize that Ashok was actually probably hired in that case in front of Andrej Karpathy, who would have been working at gosh, he might have still been a student back then, but he was certainly working at OpenAI before he was not purchased, but whatever, moved over to Tesla, and then of course is back at OpenAI now. So yeah, very interesting.
Very interesting. Okay, so just to set the stage even some more, this is just a nice little video or clip. I don't remember which person tweeted this out. I apologize if I didn't give you recognition, but basically it was just nice showing that this is what it was in 2021 and this is what it looks like, the visualization and the labeling in 2023. So in just 2 years, the significant improvement in ability to recognize and understand the world of the scenes that are driving. So that's a big deal. Now, I'm going to give everybody a sneak peek of what's about to come, just to get a little bit of understanding what we're talking about here. So this is the technology that they've now created. It's a 3D reconstruction. What you're seeing here is not video. This is many Teslas have driven through this, this intersection, this street, and then now after taking all those clips or those video clips, the computer system can now reconstruct everything. But you can see it is not just the lanes and the roads. They can track everything. They can see cars. They can see the curbs. They can see the street signs. They can see the road markings and so forth. So with this ability to reconstruct this, almost like a video game, they can do simulations. They can do auto labeling, and they can rerun and let the computer practice this in significant, kind of like in real ways. So they also said there's no need for a LiDAR system because this ability to do this is within centimeters and millimeters, right? So just a high level before we get to the details, John, what is your thinking about this new technology that they created?
Well, So something that really stood out to me that probably most people wouldn't even notice is the fact that it doesn't flicker, it doesn't move. So again, this looks like you're driving. It looks like you're just taking, you know, your camera and just like recording a scene, right, driving through it. And it looks like a pretty low resolution version of that, like maybe an old digital camera from like the 1990s. And so you're like, well, what's the big deal? Well, the big deal is that this is essentially it's a ray traced version of the scene. It's like shooting out from the car. It's looking at all of the photons that are coming in. So it's not ray traced, it's backwards of that. But anyway, it's reconstructing that scene from what the car is seeing. And the fact that things are not going like this and jiggling around. And actually, if you go back to that visualization thing, the very first thing that you showed with the 2021 versus 2023, the original one, not just was it boxes and stuff, but if people who've been driving this for a long time will, I'm sure, remember that the cars and the lanes and everything would go like this all the time. Mm-hmm. They wiggle. And what that was the inability of the software of the neural networks and also the software 1.0 to maintain understanding of the world. You could kind of consider jitter a way of like a metric of like how well it understands the world. So if you see something nowadays, when you drive full self-driving beta, like the cars that are around you, when you visualize it, they're pretty rock solid. They don't really move around very much. Now, still some of the lanes and intersections do a little bit, but back in the day, in the early days of this stuff, they were just constantly jiggling around. And this NERF, which is neural radiance field, which is what that 3D reconstruction thing was, the fact that is not, that all the things are not like jiggling and moving around as the car is driving through it is remarkable. It indicates how not just solidly the car, the computers are reconstructing these scenes, but how consistent over time it is, how they're not flickering. And it's just, that was the part that blew me away. Probably the last thing on most people's minds. Probably nobody was thinking about that part of it, but that's the part that I was like, holy mackerel, that's amazing that's happening.
Yeah. Before we backtrack and explain everything in detail, let's just get right to it. John, tell me. Like for me, this general world model allows them to create simulations that are so precise. And in addition to that, the Dojo supercomputer coming online. This is why I think that Elon has so much confidence that it might actually be solved this year. Now, every single year he has made that statement, and every single year he's been proven wrong. And that's because the neural nets that they built, my understanding is that they hit a local maximum. He thought that, exponential curve, it'll solve everything, and it doesn't. But what he has on hand now that he didn't have last year is a supercomputer that went online. And then secondly, this ability that they did where they took the technology that everybody's aware of today, the large language model technology to be able to create the generative text that we're seeing with OpenAI and ChatGPT. They took that and applied that to what we're seeing today. And so this is being reconstructed. It's predicting the future. It's trying to understand what might actually happen. And so now when you take all that, you can do huge simulations, and then the preciseness of what it can track. It can see road signs and every little detail, even like I said, to the centimeters, to the curb height and so forth. And so once a Tesla and multiple Teslas have driven through a certain road or city, it can map it. And so theoretically, they could take San Francisco today and do a Google map thing on it, and you would not be, you can go in every angle and be able to see San Francisco way better than just pictures and video that Google does, because it doesn't just show you a 3D. It's a 3D so forth, but it's self-learning also, right? So anyways, I'm very, very confident that at this point, I believe that all these edge cases that people are worried about, the 99.999%, it can be solved now, and it will be done by next year. Probably not this year, but certainly by next year. What is your opinion about this?
Wow. Okay. So there's so much to unpack and all that. So I want to actually touch on the reconstruction scene that you showed is actually not the one that's the most important one. There's another one that looks kind of crappy, and it's the one where he says like continue straight and go right. and you see two different recordings that are side by side. And it was towards the end of his presentation. I'm not sure if you've got that queued up, but anyway, we'll touch on that later. So the first thing is that the amount of compute is a huge, like in the is full self-driving going to be solved in 2024? There's the plus column and then the minus column. And in the plus column, of course, is the fact that they are increasing their compute incredibly. And I actually had a conversation with Warren Redlick on his channel yesterday. And I was saying what most people don't realize, and I have a lot of experience doing this both with machine learning, but also with just rendering out 3D animations and stuff, is that people are like, well, who cares how much compute you have? Because if it takes 7 days to like go through a front to back training session for your neural network, well, that's not a big deal. It's only 7 days. The problem is that you usually do somewhere between 100 and 1,000 versions of that before you get it right. So you're then looking at potentially 700 days, right? Not 7 days. So it's something where you're like, oh, that's why having 100 times more compute power or something really matters, because then you're reducing something that's about 2 years worth of like compute time down to like a week. And that's the reason it matters. It's not so much if you could just get it perfect the first time and train it once, that would be great. But that's not the way the real world works. You just do it and you do it and you do it and you do it. And so the faster you can turn that around, the more times you can iterate and the more mistakes you can make and the faster you can learn and the faster you're going to get to the right answer. So that is a huge plus, in the plus column that we have Dojo coming online. They're purchasing as many, I think it's H100s now, not A100s anyway, but they're purchasing as much stuff from NVIDIA. They're building the Dojo chips as fast as they can. They're bringing this stuff online to get to as many exaflops of compute as possible. That's a big plus. The big minus, and the reason why I've become actually less confident in at the same time that Elon said it's not going to be beta by the end of the year. My concern is that it sounds to me, and this is kind of the topic du jour that we're talking about here, is that they're making a fundamental change to the architecture of these neural networks. Now, that brings with it, that's the, 2 steps forward, 1 step back kind of thing, right? When you do a change like that, the opportunity to have it go backwards is huge. Even if eventually you get more headroom and the local maximum gets higher, at the beginning, it could be way, way worse. So it could take a lot of time. Now, what we don't know, none of us know, except for the folks working at Tesla, is how far along they are. Because you could tell both Phil and Ashok's presentations, they were kind of like, yeah, we're telling you about this stuff, but we're not telling you about this stuff. And they kind of mention a few other things, but they're holding it very close to the vest. So at a rough prediction, I'm going to take a guess that if AI Day happens somewhere around the end of September, early October, something in that area, that would be about the time that they would give us some updates about the timing of this new foundation model they're working on. And so they might be a lot further along than they're actually admitting right now, which of course would then give you more confidence that it's going to happen. So, we're kind of speculating without all of the information. And
sure, of course. Yeah, that's what we do. Okay, well, I do have the video queued up for the labeling of the prompts that you were talking about. But I also have that little clip where Ashok was asked at the end of the presentation, and he said very clearly he thinks that this is going to be in customers' hands. Everything we're going to show you here today, it's going to be in customers' hands by the end of this year.
So if you can do that one, that'd be great. Do that one first, because we'll talk about it.
Okay, good. Let me do that one first. Then I'll get 20. Cool. Okay, so you're very conservative still, but I
actually was less conservative before. It's one of those like, they're making.
You started off that way, and then okay, let me go ahead and play this.
I guess it's once bit, twice shy kind of a situation.
The inference times for this model, can I expect to see it on a car?
Oh, hold on.
Yeah, that's the question. Right?
I really enjoyed it. I'm very curious about your general world model. So I'm like a big fan of Tesla, and I want to know what's like the inference times for this model.
I think that is.
Make sure that the planning system.
Was that it? It was a woman that asked.
I think he answers that question right there.
I'm very curious about your general world model. So I'm like a big fan of Tesla, and I want to know what's like the inference times for this model. Can I expect to see it on a car anytime soon? Yeah.
The only thing I can say is that it hasn't shipped to customers yet, and we are still optimizing it. Maybe later this year. I don't know.
Oh, sorry.
Right.
Yeah.
That's about it. Yeah, I was like, that is the best pregnant pause ever. He's like, how much can I say right now? You could see the wheels turning in his head. So that was great. I just love that moment. I was like, oh, okay, I see what's going on here.
Come on, John. That was very confident. He said later this year. It's not.
Yeah, but the thing is, like, I had this feeling that he wanted to say like 6 weeks or something, and so he was being a little conservative in that. So yeah, anyway, and let's also counterbalance that. It's not like I know Ashok personally or something, but at least from what I've seen, he tends to be a little less optimism biased than Elon in terms of his public proclamations. So if he says something like that, I'm going to take that even more seriously than when Elon does, because Elon is just, which is great. I mean, you got to be that kind of a person in order to make the world change. You have to be like, I can make this happen in 6 weeks. And it's like, oh, it took 10 years. Whoops. So you have to have that kind of crazy optimism. But Ashok is a little more conservative. And so when he says that, I'm like, okay, we can actually be confident that that is going to happen. So yeah.
But okay, well, so first of all, I'm not saying the end of this year, Elon is. I'm saying next year for sure. And then here's why. We're going to show you all the videos, and what they're showing you now is happening, and it's already shown them that it's working. And you can hear that in the way that they explain things. I was surprised that this worked. I was surprised that that worked.
Right.
And so anyways, okay, let's get to it. Should we go to that labeling first, or should I go and just start with kind of like the general path of what are we talking about?
Do that like that generative one, the one that looks really bad, but actually is hugely important. This was also Tesla AI tweeted this out around the same time he did his presentation too.
Wait, are you talking about the prompts or something else?
The one where they said like go straight or go right. It was towards the end of
the prompts.
Yeah.
That's 1523. So, so this is the ability for, once you've created this simulation, they're able to now give it instructions. And then later, Ashok actually said, this is everything you're hearing, by the way, today, everything applies to the bots. And he says, they say that throughout the presentation. And then the same thing you're going to see here, Ashok says, this is what we will tell the bot to pick up the apple. So let's go and play.
Earlier, the car is able to, or the model is able to predict all of the geometry flow by very nicely and understands 3D. On the right here, we're asking to change lanes to the right side. Maybe we'll go back and play it again. So on the left, it's just going straight. And we ask it to go straight, the model goes straight. And then on the right side, we ask it to make a lane change, and it makes a lane change. And the past context is the same for both of these outputs. So given the same past, and when we ask it for different futures, the model is able to produce or like imagine different futures. This is super powerful because now you have essentially a neural network simulator that can simulate different futures based on different actions. And unlike a traditional game simulator, this is way more powerful because it can represent things that are very hard to describe in an explicit system. I'll show a few more examples, but then it is super powerful, and also the motion, the intention, and then the natural behavior of other objects such as vehicles is very hard to represent explicitly, but in this world it's very easy to represent.
Yeah, that's probably adequate.
It doesn't have to stop with just all right.
Okay.
So yeah, go ahead.
Yeah, can I just quickly say though that what we saw there, I'm just going to show it again. What we saw there were actually. You
can obviously do this kind of future prediction task, not very nicely.
Boom. Okay, what you're seeing here are not video. This is not video. Every single one of these is generated by the neural net system. this is what it just looks so clear. It looks so beautiful. You think that these are videos, and you can see that these are what is it, 7 cameras, and every camera angle is being generated by the computer. And he was shocked to see that this angle here is exactly what you saw when you drove by it in the front bar. So the system figured out already how to generate this, and this is all they're just creating them. They're just creating on their own, and they're predicting the future based on what the past that they had seen in the videos. Okay, go ahead, John.
So yeah, so it's really important. Tesla has talked about previously, like the AI days and stuff. They're like, we have a simulator that we run in Unreal Engine where we're able to fake driving, right? So you can put the car in situations that you don't want to, dogs and people run out in front of it and it's got to stop for them and all that stuff. This is really, really different than that. That is just kind of like, it's like a game, right? That would be like just like Call of Duty or something, except it's driver of duty, right? So you're driving in there. This is the same thing essentially as what we see with something like ChatGPT in the linguistic realm. So what you're doing is you're giving it a prior. So like when you talk to ChatGPT, you say like, you could give it something like, the big fluffy orange cat, and then you could say, please complete this sentence or something, right? And what happens is that you've given it a prior, which is the first half of a sentence or often a question to ChatGPT, and then it's responsible for figuring out what the future is. Now, what we're looking at here is the same exact thing in the real world. They're like, here, you've been driving down the road thus far, and then they block out the rest of it. And they're like, now you tell me what the future looks like. Generate those images out of nothing. And then also, by the way, we're going to tell you in one situation to drive straight and in one situation to pull into the right lane. And that we're going to see that, we're going to see the differences between those. But what is hugely, hugely important here is that it's generating this stuff on the fly. This is the same thing as asking Midjourney or something to draw you a picture of, a witch on the moon or something, right? It's that sort of a thing. It's actually generating these images as we go. Notice that the images do not flicker. They're super, super solid in the way that they actually consistently maintain over time. They look very, very realistic. I said they kind of look crappy, and the reason why is because, of course, the cameras that what Tesla's doing with these cameras is that they're not pre-processing the images. They're taking the raw photons in. And so there's a log gamma curve, and that's all technical and stuff, but it just looks really flat and boring. But that's on purpose because they don't really want to pre-process the images. They want to take that direct photon stuff. So when you see it projected back again, it looks pretty boring and pretty flat, but that's intentional. But all of that stuff is not real. None of those images are real, at least if we believe what he's saying. Of course, obviously, he could be lying, but assuming what Ashok is talking about here is correct, and what Tesla AI has tweeted out themselves, this stuff is all being generated by the computer telling what the future is going to look like. So it's making predictions about the world based on the past, and I think that's amazing. It's so much harder to do that for the real world than for language, like so much harder. And yet they're able to do something like that. Crazy.
Hey there, thank you for joining me. If you can, please consider supporting this channel so I can keep it going. It's a lot of work arranging all these amazing interviews. One of the easiest ways is just to click that join button and become a member of the channel. Thank you very much. Let's get brighter. Right. And then we're going to get into auto labeling, right? Because once you have that ability to take videos of the past, every time a Tesla has driven through any city, any location,
right,
it takes all of those videos, it feeds it into this system, and then this computer is now able to generate.
I think you're actually conflating two things here.
Okay.
So,
yeah.
Okay. And labeling, I actually want to talk about that because that's an important point to talk about. But the reconstruction, that first one that you showed with the thing with driving by the trucks and going through that 3D scene, that's a whole different thing. That is being utilized to create a ground truth for the car. And that's where the multi-trips and all that stuff come in. And you get all the cars collecting data, and it's able to reconstruct this real world scene out of that. The second clip, the one that was just the camera angles and stuff, that's generative. That is not reconstructing reality. It's constructing reality. It's actually making the future exist. It doesn't have access to that information. So in one case, you're reconstructing the real world, and you can utilize that to teach the computer, where it's like, we'll teach the car.
Okay.
what it was doing wrong or something along those lines, or where things were, and you can label it and all that stuff. In the second instance, it's actually generating that on the fly. It's not. So in the first instance, it's real world. and you're
What?
taking it in,
Okay.
reprojecting it. In the second
Oh
instance,
my
you
God.
are
Okay.
creating it. Yeah, exactly. Right.
Okay, my
Now
mind
you
just blew.
understand. Exactly.
My mind just blew. Okay. Let me just,
Yeah,
oh my
yeah.
God.
You
Okay.
gotta think through this one, right? Because it's like, whoa, that is amazing. Yeah. Okay, now
Okay.
let that one sink in for a second.
Right. Okay. Well, let's have the audience figure this out themselves too. So they got to watch this section here to actually see this. What we're going to watch first, I should have done this in order then. But
That's
that
fine.
first thing that we're doing is every time your car drives through any scenario, it captures that video. It
Right.
takes everybody's videos of that particular city in every angle, and then it's
Right.
able to reconstruct that scene. And like I said, every angle, every centimeter, every curb, everything.
Right.
Then later, this thing is a computer learning on its own, and it's able to now know it knows the world already. So it's now going to show you a world,
Right.
and it can predict what it's going to look like
Exactly.
as we drive forward. And then, oh God, okay.
So
Okay.
again,
And it's like, so what, yeah.
The ChatGPT analogy is probably going to be helpful to understand this. So again, you ask ChatGPT a prompt, a question, and it answers it. But what it's doing is it's filling in the most probable words that should sequence out next,
Yes.
right? Which is
Okay.
why I gave you can give it a half of a sentence and it'll do the rest of that sentence. And that's a good example of this. Here, what they did was they gave it half of a driving scenario, and then they stopped and they're like, okay, this is the 5 seconds of driving that you've had thus far. Now tell me what the world looks like every frame into the future. And I would expect over time it would eventually start to disintegrate. It wouldn't work for a
Hallucinate.
huge amount of time, but it works for several seconds. You can see it. It's reconstructing It's not reconstructing, sorry, constructing reality. It's making up what the probable future is. And that's the reason why, and the fact that it's action conditions, it's super cool because it's like drive straight. Well, it's like, okay, the probable future is I'm going to continue like this. Go to the right lane. Oh, the probable future is I'm going to go like this. So it's generating what it imagines the future is going to look like. It's not reconstructing anything.
Okay. And is it true to say then that given that capability, what you just described, now you can have a supercomputer, you can run it like 1,000,000 times, 1,000,000,000 times, let it run against itself until it just gets every edge case, figures things out on its own. You can just play against each other.
Right.
As
And now
opposed to
we
having
touch
to,
on now we touch on the reason why this is so profound and why it's such a big change. All this stuff about labeling and everything is fantabulous. This is a great bootstrapping step, but what they're telling me, I think what they're saying, and they're not saying it super explicitly yet, is that this is we don't need labels anymore. This is what this foundational world model is. This is end to end. This is like you start with the photons, you end up with an output control, whether that's Optimus moving his arms or whether it's the steering wheel turning and the accelerator, pedal being pushed or something. From end to end, you're not telling it anything explicitly. You're just saying, here is the world. You figure it out. So you're no longer saying this is a car, this is a curb, this is a street light, this is some smoke. That was one of the examples that Ashok talked about, because they've got the occupancy network, and the occupancy network is amazing. And it was something that he told me he did I think he told me personally, or maybe he said that as part of the presentation, but he did it as a weekend project. It was just his own thing. He was like, oh, let's try this and see if it works. And it turned out to be super important. But what that is a good intermediate step, but it still requires labels and external semantics. Human beings have to say, this is something, this is something, this is something. The problem is, and when he does that thing about smoke, where he shows like, oh, papers flying everywhere, smoke in the air, occupancy networks can't handle that because it's something where it's just so complex. A human being can't label that, like every one of those crazy instances that exists. So the best way to teach it, but it's always been computationally intractable, and hint, hint, that's the reason why 100 exaflops is important, is that what you need to do is teach it just like a baby. What does a baby do? A baby invents their own, even if this child was not given access to, you get that hypothetical child raised by wolves or something. So it doesn't have a language. It doesn't have any way of describing the world linguistically, but what it does is it learns to label the world in some internal sense. And that's what's happening with this, with the full self-driving. I think that's what the next thing they're working on is. And that's why I'm a little bit like, ooh, I don't know if they'll get this solved right away, because this is like such a big foundational change. It's basically throwing away all the stuff that they have right now and starting over again in kind of a way. And so the whole goal, though, is to teach it like a person would learn. You just interact with the world, and you interact with the world, and you figure out your own internal grammar of how the world operates, including things like whether or not you have the word for smoke. But like if you're running fast or driving and there's this big cloud of smoke, you're like, okay, I need to be a little careful because I can't see very far, but that's not something that it's not like a wall that I'm going to hit with my forehead. So you're not going to have a situation like that happen. And it's just hard to overstate how profound this is. This has been done in Google's DeepMind. They did some stuff with
I was going to say this.
Dudes that ran around and or was it OpenAI? Crap, I could be wrong about it.
It was OpenAI.
It was OpenAI. I'm very sorry about that. Yeah. Sorry, OpenAI. Got to give credit where it's due. But they had their hide and seek thing where these guys are running around and they figured out the rules of the world and how to cheat. Like they could throw things over walls and stuff like that. So, but that's a very easy world because it's just like it's a level up from a chessboard. You know, there's not that many rules. There's not much reality, but everyone has always been like, this is just intractable in the real world because the real world is too complicated. What we get from this, though, is Tesla's going like, nope, we think we can do this. We think we can actually solve it. One of the reasons why is because they just have so much freaking data. And they also have these other, when I say labeling and the occupancy network are not necessary, that's not true. They're necessary to train up a model that can get to this point and to create realities in that 3D reconstruction of the reality. All of that stuff is necessary to get us to the point where, and then all the exaflops of compute, where this thing can actually learn a foundational model. But if I'm right, I think it's all of the architecture that they have right now is not eventually going to be in the full self-driving computer. It's going to be a whole different architecture that's just going to learn end to end. It's going to be, here's the input, here's the output. Whether you're Optimus or the car, it's going to be a flat out learn it like a baby does, that kind of a thing.
Okay. John, I am now even more optimistic. Okay. I don't agree with you at all. Here's why.
Okay. Well, that's why I got a little bit concerned, because I was like, there's a lot of work to be done if they're doing this. This is a huge change.
But no one's going to have to do that work except the computer. So it just, let's go back and what happened with Google's DeepMind when they were trying to solve the hardest game in the world, the Chinese game of Go. It is like so computationally, it's like more moves than atoms that exist in the world. And initially what they did was they showed it videos of humans playing against humans, and they had the computer play against the human, and it took them years, whatever, and then finally it was able to beat the best human player ever in Go. Then they created a new version, AlphaGo, and what they did here was they just did not even input anything at all. They just said, here's a board, here's the pieces of white and black, play against each other. And then it solved it within days, like 17 days or something like that. And it was so superhuman at that point. And so the computer played against the computer. And then because they did that, it learned the world of Go, and it was able to figure this out to the point where it started making moves that no human would have ever made. And humans are still confused why they made that one move at that one particular situation. But it is so better than anything at this point. So that was a faster way to solve it, and it solved it on its own and learned it. And so what I understand that this is
it had to have the first solution first.
Sure.
Like there was a level at which it had to understand things. But this is why I'm saying, like, all of the stuff that Tesla has done, it's not like, oh, that's entirely wasted time. It's like it's all necessary steps. But yeah, it's like Go, except Go on steroids, because the real universe is incredibly complicated.
So now that you've described this to me as it's a neural net, like learning on its own, this new world, creating reality, right? Not reconstructing 3D reality, but actually constructing reality. So now it makes sense what they were saying in that video. So they said things like, it figured out 3D on its own. So it kind of first thought it was 2 dimensions, and then nobody had to teach it that, that tree is further behind than this fire hydrant. it knew the distance and it figured that on its own, just like a baby would walking out through the world. At first, it might go, what the hell am I looking at? Eventually, as it interacts with it, it kind of knows. And then the point about the smoke and the paper makes a lot of sense. So my understanding is this, right? They had built the technology for occupancy network, and this is the ability for the vision labeling to be able to know if a pixel was filled or not filled, and if it's moving or not moving. And so it's just very crude. They don't have to label it. They just knew if that is occupied or not occupied. And so then the car, and that is active in our cars today, apparently. It can now do evasive maneuvers. It immediately know if some area is occupied or not and not hit things. Okay, so it does that. This system, the problem with that system, though, is what happens if there's smoke. So if there's smoke filling your screen, you don't know if that's, you would think that you better not drive because you're going to hit things. And what if there's paper flying? And then that looks like it's something that I'm going to have to, it's clearly a physical object, I better not hit it. This system on its own learned that is smoke and that is paper. I don't know if it labeled it necessarily, but it knew that I can drive through that. That's an example of an edge case that people used to describe that was impossible for the system, but it learned it on its own. Nobody had to teach it. And that's why, you just let it run on its own and it'll figure this stuff out.
Exactly.
Is that right? What I just said?
Yeah, exactly. And that's the reason why, you're absolutely right. The more you can take humans out of the loop of this, the better, because we're slow. We're so slow. We're so many thousands of times slower than a computer to like label something or whatever. So, but once you can reconstruct reality in the sense of creating those three-dimensional worlds and everything, then you could put the car into that world. You can give it prior. So again, I think the large language model analogy is really, really useful here. You give it words and then it continues those words on. Here, what you're doing is you're giving it photons. You're giving it all of these images and you're saying, okay, there it is. Figure it out. What's going on right now? And then the way it learns is it says, okay, the next second, this is going to happen. And then you have the real footage and it's like, nope, you're wrong. And then it's like, oh, let me try again. The next second, this is going to happen. It's like, no, you're wrong, but you're a little bit less wrong. Next second, you're wrong, but a little bit less wrong. And eventually it kind of matches up. But in order to do that, the same thing that goes on with the large language model, a lot of people are like, and I have to say that I was one of these people. I was a little bit kind of flippant about this. I was like, it's just a fancy autocomplete. It's just like, the stuff when you're typing and it figures out the next word. But in order to really, really fill out the next word correctly in a complex situation, large language models have to understand language and they also have to understand humans. They have to know what the heck a human is and to some extent what we're doing. What is it that we are actually asking? What is the intent behind this question? That requires a lot. And so you're looking at full self-driving over here, having to understand the world. And that means that it's creating its own internal language and words and vocabulary. Nothing that we would understand. It's all just going to look like a bunch of numbers. But those numbers internally, just like with something like ChatGPT, are a way of representing reality and a way of representing things, weird stuff like smoke. And the simpler things like another car or a road, which is not that simple. But anyway, it's the way it builds that up, but it's building it up internally. A human doesn't have to say, this is a road. This is a road. Oh, this is also a road. This is still a road. That's boring. And it takes forever because a human can't possibly label everything within the history of the universe. It'll take forever. So what you've got is a computer that can go way faster as long as it can learn on its own. And that is when I watch these videos, my mind, just like what you did when I was watching the video, I wasn't recording myself, but I was like, holy crap.
It's a big deal. It's a big deal. So I know this is awesome, amazing. I want to show people the actual video clips so that they can absorb it themselves directly from Ashok himself. So there's several clips I want to show. The first one, of course, is let's get back to this 3D reconstruction. So when a car has driven through a same street seats, and then after that, we'll do the auto labeling. And then maybe some other clips of him.
If you do that occupancy network where he shows the one with all the little pictures with the smoke, that would actually be useful too, because that's the place where the occupancy network kind of falls apart. So yeah.
Perfect. Okay, I do want to we have to start at the beginning, I think. So
that's why we are working on learning a more general world model that can really just represent arbitrary things. So in this case, what we do is we have a neural network that can be conditioned on the past or other things to predict the future. And I mean, obviously, everyone has wanted to work on this forever. And I think with the recent rise in generative models like, transformers, diffusion, etc., we finally have a shot at it. So what you're seeing here is purely generated video sequences. Given the past videos, the network predicts some sample from the future, hopefully the most likely sample. And you can see that it is being predicted not just for one camera, but it predicts all the 8 cameras around the car jointly. And you can see how the car colors are consistent across the cameras. The motion of objects is consistent in 3D, even though we have not explicitly asked it to do anything in 3D or not even baked in any 3D priors. This is just the network understanding depth and motion on its own without us informing it of so. And since this is all just predicting future, RGB values, the ontology is quite general. You can throw any video clip from driving or from YouTube or from your own phone. Anything can be used to train this general dynamics model of the world. Additionally, it can also be action conditioned. We can show a few examples. So here on the left side.
What's that?
Oh, I was just saying, it's a really interesting little tidbit that he says, specifically that you could like upload YouTube videos or home videos or something like that. That's really, really intriguing. But yeah, hopefully after listening to this conversation, when you heard what he talked about, you're like, oh, this makes sense now. One thing that's really interesting is that the bottom of that slide on the left, it said generalizes to out of distribution. And what that means is effectively that it can do something it's never seen before. So like a situation where, again, you're driving in a place that it's never driven before for somehow, you're just whatever. You're someplace that the car has never been. It will still be able to figure it out. That's what that generalizes to out of distribution means. So that's actually a very important point in terms of the way that it's able to work. But it also means it can work on weird things like YouTube videos and stuff that have nothing to do with driving. But it would be really interesting to see what Tesla's full self-driving would dream up from this conversation. Give it half the conversation and see what it does, what we look like over time. So yeah. But again,
let me play this part here.
Pardon me?
Let me play this. Let me play this part here.
This structure of trajectories, calibration from all these cameras, you can really do a lot of cool things to reconstruct the entire scene. I'm not sure if the video plays quite nicely, but in my own screen, it looks very smooth, where you can see the ground surface. It's reconstructed quite nicely. There's no artifacts such as double vision or blurring. Things are crisp, look like geometric, they are correct. This is a hybrid approach to NERV and general 3D reconstruction. Sometimes in NERV, even though the re-rendered visuals might look very nice, the underlying geometry might be very fuzzy and cloudy. So we have a hybrid approach, which works quite nicely. You can see here, the barriers, the vehicles, even trucks, etc., are reconstructed pretty accurately.
All right. So tell us what you saw there. What was that?
So again, this is in some senses, this is like old news. So
right.
I think it's because we saw a lot of this at AI Day 2 last fall. Not to take anything away from this. This is amazing. So this would be what he called a hybrid NERV solution. I don't know exactly what he means by the hybrid part because they didn't explain it. But a NERV is a neural radiance field, and I talked about that a little bit before. It's taking the photons in from the world and then reprojecting them back out again to try to recreate a 3D scene. So it's basically a 2D to 3D transformer. Not transformer like the large language model transformers, but I mean a spatial transformer. So what you're doing is you're taking all of these camera angles and then you're taking that stuff in, and out of that you're projecting a depth situation. You're projecting where all these things are, and then of course you can label that and all of that on top of it. Now nerfs have been around for still frame images for a little while. I mean, not that many years, but to do this for video and have it be that consistent frame to frame and not have flickering and blurring and double vision, which is all the stuff he said, is really remarkable. Like it's an engineering marvel. I don't know if this is foundationally new, but it's certainly engineering wise really impressive. So in other words, they've built, I believe, on other people's research here, but what they have done is done an incredible job of engineering this into a state where it can work for video and not just still frame images. So it's pretty impressive stuff.
Okay. And I'm going to play the part about auto labeling. So this is, that was 3D reconstruction of every car that's driven through any intersection. They can reconstruct it now, and then they can then post-process the auto labeling afterwards, correct? And that teaches the system much faster. Let me go ahead and play that part.
Once we have these reconstructions, we then run even more neural networks just offline to produce the labels that we want. Like I had mentioned earlier, for lanes, we need some kind of vector representation to make it very easy to use. So instead of just using raster directly, take rasters, we have offline neural networks that run on top of it and then produce the vector representation that can be then used as labels for the online stack. Similar to the lanes, like once you have the lanes and the roads reconstructed, you can also auto-label traffic lights. Here you're seeing traffic lights auto-labeled by our system without any human inputs. And these are all like multi-view consistent. Let me try to play it again. Yeah, we can predict their shape, color, relevancy. You can see this white traffic lights on the side. They also reproject correctly into all the camera views. And it's because we have this really good auto labeling system that calibrates everything jointly and it's like pixel perfect in 3D space. Okay.
So, yeah, explain what you said.
Okay. So again, this is, I'm in this weird sort of state because all of this stuff is so impressive, but I also feel like like I said, it's a stepping stone. And so I think a lot of this is going to go away, but it's a very important stepping stone. It's a semantic understanding of the world. So what they have been able to do, and this is as important as anything that's in your car, is this whole auto labeling pipeline that they've created. More important probably because it actually creates the data that they need to train it. But what it is a method of the computer, like the neural networks, teaching themselves what everything is. So it's like, is that a car? Is that a traffic light? Is that a truck? Is that a road? Whatever is it a background object like a tree that I don't need to care about? All of those sorts of things have to be labeled. And at the beginning of this process, it was all humans labeling this, and it was incredibly tedious. And I think last I heard, I think they said they had like 1,000 plus labelers, just people who are just sitting there labeling. Now, they've got tools that make that a lot easier now. They can do video labeling as opposed to just individual frame labeling. So in other words, if there's a car over a 20-second video clip, you only have to kind of label that once and then it figures out where all of that is. But then more importantly than that, because there's only so fast a human can work, more importantly than that is teaching the computer to do the labeling on its own so that a human never has to intervene, because as you were saying, computers, you're like, this is the whole reason why you want to get humans out of the loop is, again, because we're very slow. You want to be able to have this thing work on its own and be able to do the labeling on its own. So that part is critically important. But again, if I'm right about this stuff, labeling is not going to be the end all be all in the next version of the software. But it is super important to teach the computer to get up to a state that it's, I guess that AlphaGo analogy is really good. The AlphaGo 0 or whatever the one was that the humans taught it and it took several years, that was critical. They couldn't teach the other one until they had a system that understood the world well enough to be able to play the game of Go at that high level. Then what they could do is they could train a sort of another version on top of that utilized that information as a starting point, but was then able to ratchet up very, very rapidly in just a few days to get way, way better than the old version was, and to get infinitely better than humans are. And to the extent that we don't even understand exactly what it does, like you said. So it's that same sort of thing. All of these are necessary steps to get the model up to a level that it needs to be and to understand the world relatively well enough that we get to that point. But then what we're doing is we're moving to the next iteration. It's the next like evolutionary step in this. And that evolutionary step is for it to create its own grammar, not have humans tell it what it is, but for it to know what it is internally. Whatever words or numbers or things it uses, it has its own internal representation of what's going on. So that's the difference.
Okay.
Yep.
Thank you for explaining all of this, John. This is fantastic. So just to not confuse the audience members,
Right.
we kind of intermixed a little bit of the future tech and the current tech. The current tech that we showed is actually very important. So we showed you that video where it can do 3D reconstruction of any Tesla driving through a certain instruction. They can reconstruct it. We just showed you the ability for it to do auto labeling on that video that it was doing it. And then we also, at the beginning of this episode, and we're going to show you now, it's now evolved to take that information, but now create reality itself, generate reality itself, and make decisions on its own. And that's a part. So I'm going
to be clear, the first part you were talking about and occupancy network and stuff, if you're driving full self-driving beta right now, that's what you're using.
There.
This other stuff is what's supposedly coming by the end of the year to us normal human beings. I would imagine that the testers are already driving things like this, or at least in simulation they are.
Okay. So now what we're going to talk about is generating reality and this ability to, the system taught itself smoke and paper. And so let's play
exciting
that part.
future that we are working on here. Yeah, here's some examples where I think, something like this is going to be needed to represent like what's happening in the scene. Like there's a lot of smoke coming in one of the pictures, like there's paper flying everywhere. That's going to be tough for, even occupancy where, okay, you have paper flying everywhere. There's occupancy flow, but then how do you know it's paper? What do you know the material properties of it? There's like smoke, obviously you can drive through it, but it is occupying space and light does not transmit through. There's a lot of nuances to driving, and we have to really solve all of these problems to build a general driving stack that can drive anywhere in the world and be human-like, be fast, efficient at all speeds, yet very safe. And I think we're working on the right recipe for building this.
All right. Oh, and then we get to the exaflops. Yeah. So that's the critical thing. So he even explicitly says occupancy networks have a hard time with these cases. And there's a lot, but he specifically talked about the two kind of in the middle, the smoke one and the paper one. And those are situations that as a human being, kind of your understanding of the world is going to kick in at that point, like whether it's smoke or whether it's those giant sheets of paper kind of blowing around, that you're going to have to go like, ooh, do I just drive through this, or do I have to stop, or can I like dodge it, or something along those lines? And those are the kinds of things, like how there are so many, I think Ashok says nuances, there are so many little details and differences between everything in the world that there is no way that a human being is ever going to be able to explicitly say every single possible case to a computer. And that's basically what he's talking about here. He's like, we've got to do a new way of doing this where the computer figures it out for itself and we don't have to tell it everything. Difference between going to school and learning a subject in class where the teacher will teach you a certain amount of things, but then you get out into the real world and maybe that's your job or something. And you're like, oh my gosh, there's so many more little possibilities for the way that this could go than what I've seen before. And so you learn, reality is a really good teacher effectively. It'll teach you what you need to know eventually, but it requires immense amounts of compute power, which we humans have up here in order to make that happen.
Okay. All right. So let's get back to what's happening today. So we know that everybody has version 11.4.4 that's being rolled out. Elon has said that version 11.4 should actually be version 12 because it's so major improvements already. But version 12 is reserved for when FSD's end-to-end AI from images in to steering, brakes, and acceleration out. And then he also says here that version 12 may be later this year. And he says it won't be beta. Can you explain those statements?
Well, I think that all relates to what we're talking about here. I believe it was not, I didn't understand this originally when he tweeted this stuff because I hadn't seen Ashok's talk, but, or at least I think I hadn't, I don't know. But I think what he's talking about right here is that this is going to be the new sort of foundation world model that is going to be an end-to-end trained system. George Hotz, by the way, who's Comma AI's like founder and CEO, he also has been very, very adamant that end-to-end solutions are the way that these things are going to have to work. But it's that end-to-end solution. It's a kind of world building, world understanding network that takes in the photons in the cameras to start with and outputs some control sequence. And again, like you said earlier on, everything that we're talking about here counts for Optimus as well. Optimus has a little bit easier time in terms of the speed it's going because it's moving much slower than a car, but the world that it's in, inhabiting, like all of this stuff back here. Like if you said, go pick up, let's see if I can do this right. She said, like, go pick up that cup right there. Geez, I can't do it backwards. Right there. So you said, go pick up that cup. It's got to interact with a much richer world than the car does, because it's got to navigate across a floor. It's got to reach into a bookshelf. It's got to pull something out. There's a lot of steps to that. And it also has 200 plus degrees of freedom, whereas a car has about 3. So that needs end-to-end. There's a different balance between the two of them in terms of what's hard and what's not hard. For the car, it's all about the fact that it's really big and dangerous and goes fast. For a humanoid robot, it's all about the fact that the world has a lot of stuff in it, and the control output, like the body, is very complicated. For the car, the output control is relatively simple. But so anyway, so that's why this end-to-end solution is going to be beneficial to both of them for different subtleties of the two different robots. But in both of those circumstances, the world model is super, super important. The foundation model, and the fact that it can train itself. It's kind of an it's a generative pre-trained driver. GPT.
Yeah, let me play the.
Yeah.
No, don't do that. Don't do that. Don't use GPT, because this is better than GPT. I want to talk about that. But first, let me go and play this. You can hear it from Ashok himself.
Thank you for the awesome talk, Ashok. So I have one question regarding the general model, word model you just mentioned. How would that actually apply to the humanoid task? For example, manipulation, what kind of methods you use to make that generalized from autonomous driving to the other humanoid robotics tasks?
Yeah, I think the same should apply for humanoid robot, in the sense that you can prompt it to do arbitrary things. You can ask it to pick up a cup or walk to some door or something, and then the model should be able to imagine what picking up a cup would look like, or walking to a door would look like. And I don't see why it should be any different between the car and the robot. So because it's all pixels and the shapes are all the same, so it's just going to be a video that looks like the hand is reaching to a cup, or the robot, if it's a first person view, then it's a first person view of the robot, walking to the door. Like that's, I think it should work.
Cool. Yeah. So, well, I mean, think about a human. If I told you right now, I said, close your eyes, imagine walking into your kitchen, opening your refrigerator door, and I don't know if you got milk in there or something, grab a thing of milk and pour some milk out into a cup. You would be able to visualize in your head what that looks like. You're familiar with your house, right? So you could do that. And that's essentially what he's talking about. He's like, the robot, the Optimus, is going to be able to dream, imagine the future of going to pick up that cup. It's going to be like, okay, I got this. I understand what I'm supposed to do. But that visualization is really important. I don't know if you, I have relatives. My niece was a professional tennis player, and all of my family plays tennis. But like one of those big things, the psychological aspect was always like, visualize yourself winning, like have this like visualization of playing a really good match. And it's that sort of a thing. It's like that whole power of predicting the future. And we do that on a moment. You don't have to be a professional athlete to do that. You can do that moment to moment as you're walking. Maybe you're walking down a sidewalk and there's a person coming towards you. Your mind is going to start predicting, well, what if that person steps to the side, like right in front of me? What would I do, right? There's just these little calculations that are going on in your head. Probably you're not even really conscious of it usually, but that's one of the reasons why you can, generally speaking, react properly to a situation is that your brain is already kind of projecting into the future these possibilities of what could happen with probabilities of that too. So that would be like a Monte Carlo type of simulation where it's just like, let's try 1,000 different versions of the future with a probability distribution. Like these ones are the most likely to happen. These guys are really, really unlikely to happen, but they're kind of extreme. So we should probably pay attention to them. So that's what it's doing. It's just figuring out the probabilities of the future, and it's focusing down and going like, that's the most likely outcome. I'm going to go that way. That's the thing I'm going to do. And if something else weird happens, then the whole distribution shifts over and it tries to figure out what it's going to do next. But I think, even though computers are super different than humans and we have different like consciousness, all of that kind of stuff is different. I think that it's a very good analogy to think about the way that a human interacts with the world as to the way this is going to be working in the future. And I think one of the outcomes that will take place because of this, if it works well, is that some of the weird stuff where we're like, why would the car drive like that? Why would it do something that stupid? I think we will have a lot less instances of that because it will be much closer to the way a human thinks than the current version. The current version doesn't really think like a human. And this new version hopefully will think much more like a human. It will interact with the world much more like we do. So, yeah.
Love it. See, you're awesome. Thank you for describing that. The last clip here, we need to address Dojo. Let's watch what he says about Dojo, and then final thoughts.
And obviously, training all these models takes a ton of compute, and that's why Tesla is aiming to become a world leader in compute. Dojo is our training hardware that we have custom built at Tesla. That is starting production next month, essentially. And with that, we think we are on the way to become one of the top compute platforms in the entire world. And we also think that to train these foundational models for vision, we need a lot of compute, and not just compute for training this one model, but compute to try a lot of different experiments to see which models actually work well. And that's why it's super exciting for us to be in this spot where compute is going to be abundant, and it's just going to be bounded by ideas of engineers.
Yeah, I think that's pretty good. Well, I mean, he said it. Like it's if we want to do these foundation models, it's not like they already know what the right architecture is. They're going to have to try this and go like, well, that worked. They're going to have to try it again and go like, that didn't work. There's going to be iteration upon iteration upon iteration to find just the right architecture to make all of this stuff work. And it's going to require insane amounts of compute. So of course, why wouldn't they need as much as humanly possible? I think we're going to end up in the world of Amazon Web Services a little bit, because historically what happened with AWS is that Amazon, this isn't AI at all, but they needed massive amounts of compute for the Christmas holiday rush, like the 6 weeks or so before Christmas. People went crazy, but then they were like, well, what the hell are we going to do with this the rest of the year? Because we've got all of this extra compute that we built out. And they're like, well, we could just rent it out to people. And so now that's become their most profitable wing by far. And so I think that, eventually Tesla is going to get the full self-driving thing nailed. And then of course they'll turn to Optimus, but as they build more and more compute, they're going to have more and more free compute. And as they do, they will be able to rent that out to researchers who are interested in working on and having an AI accelerator that can do things really, really fast for very complicated problems. And so one of the benefits to society is, and this could take several years, I mean, we might be talking 3 to 5 years from now, but that eventually us just normal average researchers are going to have access to an insane amount of compute for a relatively inexpensive price. And that's going to be super cool. So not just for Tesla in the near term, but for us all, for humanity overall, it's going to be a really, really big deal for this 100 exaflops. And you could see that thing, it wasn't like it was like and just flatlined out like this. It was like clearly they're still thinking about going up after next year. So who knows where they're planning on stopping, but
100 exaflops next year. Okay, so just to wrap everything up, obviously, what we saw here is real world vision AI, which is way more important than just generative AI, which is the chat GPT or the pictures or the videos that we're seeing, the ones that we're seeing now, which is large language model. This is a system a neural net, a computer that can understand the world and then physically interact with it, whether it's a car or a robot. But it's like a child that's growing up and learning that a distance, maybe gravity, maybe it'll learn predicting a future of what might happen, like that stoplight might turn on in a few minutes, those kind of things. It'll figure this out on its own.
Right.
It'll know paper, it'll know those kind of things. So for me, this is the answer to the millions of edge cases that are out there. But even without the edge cases, it's going to no longer do all the stupid things that it's doing today, because it's kind of right now, it's kind of reacting in that system, versus now this is true intelligence. This is truly intelligent. It actually better than me, of knowing what to do. One thing I didn't show was the system today can actually learn. It can do, what is it called? Cross traffic emergency, automatic emergency braking.
Yes.
So when a car comes right in front of your car right now, your car, a Tesla, will stop, because it can see that a car is coming. It can predict that it's going to come in front of you. There's no other AAB systems that can do that today. It can only do this is stopping ahead of you, I better stop immediately. The cross traffic one, it's already out there. This is one example of an edge case that it figured out. Another one was parking. I saw that they worked that out, because the system knows the curb. It has the videos of all that area. It knows how to park much better than the little ultrasonic sensors that they used to have. That it's just so dumb. And people are complaining about that, but actually this has 8 cameras. It has the intelligence to figure this out. Anyways, okay, so thank you for explaining everything to us.
The future is cool. How's that? The TLDR for the whole video is the future's cool.
Oh, anyways, yeah, and Tesla is on top of everything, and I'm just so confident. Yes, if it doesn't happen the end of this year, it doesn't happen next year, it's very likely going to happen. This is a solved problem. So I'm much more confident saying that than we've ever been.
Right.
I want to hear what your statement is, and you can couch it any way.
My statement, I wouldn't be so confident as to say it's a solved problem, but I think that it's like, oh gosh, why am I Mr. Analogy today? But I always think about it like the first person who figures out how to do something new is like a person walking along in a moonless night in a forest, and they're just bumping into trees, trying to figure out their way out of the forest because they don't know which direction to go. But once they finally get there, then everyone else is like, oh, you just go that way. So, so not just Tesla, like if Tesla can figure this out, this is going to be like, it's going to open up so much to everybody else too. There will be other companies for whatever reason, whether it's full self-driving or other things, that will go like, oh, that's the way we need to go. Like, so once the first person figures it out, it becomes really easy because it is a solved problem at that point. But I think they're getting really, really close to it being a solved problem. And
I didn't mean to solve today. I meant that it will be solved now because they've got the tools in place. Everything is in place. Yeah.
Exactly. Yeah. And one of the big things that we didn't talk as much about is data. But the fact that nobody else can do this right now because nobody else has the data that Tesla has for this kind of environment. Yeah.
Okay. Thank you, John. Follow John on his YouTube channel, DrKnowItall. He has taken both Phil Duan's and Ashok's videos and presentations, and he broke it down step by step, explaining everything. I'll put those videos in the links. I've been talking about this for at least 5 or 6 videos, and I just am so blown away by your explanation. It was very important. So
yeah, and we didn't even talk about Phil's thing today at all. So definitely watch the video on that one. So yeah, there
you go. We got to watch that video. Awesome. Thanks. See you soon.
Cool. Yeah, thank you so much. I appreciate it.